Hello friends, welcome to our channel. I hope you are all in a very good health and studying well with your full focus. Thank you for joining me. Today we are going to solve some numericals which are based on mirror formula and linear magnification. So let us first take the first question. So this is our question where we have a convex mirror which forms the image of an object placed at a distance 40 centimeter in front of the mirror. So the object distance is 40 centimeter and the image distance is 10 centimeter. So we need to find the focal length of the convex mirror. So this is our image. So the question says the object distance is 40 centimeter, but this distance is measured from the pole opposite to the direction of light, so a negative sign will come with it, and the image distance is 10 centimeter. It is positive as we are measuring it in the direction of light. So now we need to find the focal length. The focal length is also positive. So by applying mirror formula we can write now let us put the values. So the value of f should be 40 by 3, which is approximately equal to 13.33 centimeter. So I hope the question and the solution is clear to you. Now let us take another question. So this is our question. A convex mirror forms an erect image of an object of size one third the size of the object. Okay. So the image is one third of the size of the object. If radius of curvature of the mirror is 36 centimeter, then find the position of the object. So we know magnification is equal to height of image by height of object, or it is equal to minus v by u. Now the height of image, if the height of the object is x, let height of the object be x. So it is x. So height of image is one third of x. Object and image both are above the principal axis, so they are positive. Now it is minus v this is our minus v by u. So we can cancel x. So it gives us v equal to minus one third u. So this is what we are getting. Now again we can apply mirror formula. Now in place of 1 by f, we can write 2 by radius of curvature. So it is 2 by radius of curvature is 36. So for a convex mirror, the radius of curvature is positive. So it is 36. So we can say this is 1 by 18. Now we are getting 1 by u plus 1 by v is equal to 1 by 18. Now if we put the value of v from the previous relation, we can write or so the value of u should be minus 36 centimeter. That means the object is placed in front of the convex mirror and the distance of it from the mirror is 36 centimeter. Now friends, let us take next question. So the question says a point source of light is kept in front of a convex mirror at a distance of 40 centimeter. The focal length of the mirror is 40 centimeter. Okay. Find the position of the image. We know in case of a convex mirror, the image formed is always a virtual image which is formed behind the mirror. So we need to find out the image distance. So let us do it. So u is minus 40 centimeter, focal length is plus 40 centimeter, and v is unknown. So by mirror formula, we can say now if we put the values of u and f, so this is the image distance which is positive. That means the image formed is behind the mirror and the image distance is 20 centimeter. So this is our answer. I hope you have understood the solution. Now friends, let us proceed to the next question. This is our question which says An object of length 4 cm is placed in front of a concave mirror at a distance of 30 cm. The focal length of the mirror is 15 cm. Where will the image form? What will be the length of the image? We know for a concave mirror, the object is placed at a distance of 30 centimeter. Okay, so the focal length is given, which is 15 centimeter. But as the focal length is being measured from the pole opposite to the direction of incident light, it should be taken negative. So the magnitude of distance of focus and pole is 15 centimeter, and the object is placed at 30 centimeter. That means the object is placed at the center of curvature. This distance is if the focal length is 15 centimeter, then the radius of curvature should be minus 30 centimeter. So this is our radius of curvature, and which is equal to the object distance. This is our focal length, and this is our object distance. So we know when the object is placed at center of curvature, the image is also formed at center of curvature, and the size of the object is equal to the size of the image. So if the object is 4 centimeter long, the image should also be 4 centimeter long. So let us calculate it using mirror formula. Question number A says, where will the image form? So the image will form in front of the mirror, and the image distance will be 30 centimeter. This is also image distance, and the question in part B says, what will be the length of the image? So the length of the image will be exactly equal to the length of the object. So if we use mirror formula to show it, we can write Focal length is given, which is 1 by minus 15. Object distance is given, which is 1 by minus 30. So V is equal to 1 by V is equal to minus 1 by 30. So V should be equal to minus 30 centimeter. So here we can see the object distance is equal to the image distance. This is our part 1, and sorry, this is our part A, and part B, we can use the formula of linear magnification, which says m equal to minus v by u equal to height of the image by height of the object. So here we need to find out hi from this relation, or we can say minus v, that means minus of minus 30, by u, that means minus 30, is equal to hi by ho, which is equal to 4 centimeter, or it gives us hi is equal to minus 4 centimeter. That means the image length, or we can say the height of the image, will be 4 centimeter, and the image will be a real image. The minus sign signifies the image is real image. Okay, so this is our solution of part B. So these are our solutions. So this question can be solved using the diagram and the concepts, or it can be solved using mirror formula and magnification and linear magnification. Now let us look at the next question. This is our question, which says a concave mirror forms a real image of an object in front of it at a distance of 30 centimeter. The image formed is real image, and the object placed is in front of the mirror at a distance of 30 centimeter. Now the size okay, so the image size is 3 times the size of the object. Now we need to find out focal length and the position of the image. Okay, so let us first write the information. U is minus 30 centimeter. We do not know. Focal length we do not know. And HI by HO is 3 by 1. For a concave mirror, the image formed is a real image. So the height of the image should be taken negative. We know for a concave mirror, if the object is placed at different positions in front of the mirror, then the nature of images formed will be different. Only in one case we observed that the image formed is virtual when the object is placed between the focus and the pole of a concave mirror, and in all other cases the images are real. So in this case, in our question, it is mentioned that the image formed is a real image. So when a real image is formed, the real image is inverted with respect to the object. So the real image is below the principal axis. So when we measure a length below the principal axis, it must be negative. We take it negative by convention. So the height of the image should be taken negative and height of the object should be taken positive. So this is what we are getting from the given information. Now this is also equal to minus V by U. So we can say, if we compare these two ratios, we can say minus V by U, which is given, U is our minus 30, is equal to minus 3 by 1. So minus minus can be cancelled. So V is minus 90 centimeter. So the image formed is a real image. It is inverted and it is formed in front of the mirror The negative sign signifies that the image formed is in front of the mirror. So this is our part B. This is the answer of part B. Okay, position of the image. Now we are solving part A. We can use mirror formula. So the focal length is 22 by zero point 0.5 centimeter. Now friends, let us look at this question which says, if you sit in a motionless car and observe in the rear view mirror, radius of curvature of that mirror is given, a jogger approaching, speed of the jogger is 5 meter per second. So the question is, how fast is the image of the jogger moving when he is 39 meter away from the car? So we know we are talking about a convex mirror, because rear view mirrors are convex mirrors. So when the jogger is 39 meter away, that means EU is 39 meter. In case of a convex mirror, U is negative, and radius of curvature is positive, which is 2 meter. So focal length is 1 meter, positive 1 meter. So we have these informations. So by applying mirror formula, we can find out V, position of the image behind the convex mirror. So let us apply mirror formula. U is given, which is minus 39. V we do not know. F is 1 by plus 1. So if we solve it, we are getting V. V should come positive. So 1 by V is equal to 1 plus 1 by 39, which is 40 by 39. So V is 39 by 40 meter. So the image formed is behind the mirror, and which is 39 by 40 meter away from the pole. Now it is mentioned that speed of the jogger is 5 meter per second. So after 1 second, the change in position is, so we can say after 1 second, the position of the jogger should be initially jogger was 39 meter away from the mirror. So it is minus 39 plus 5 meter. Why minus 39? Because initially the jogger was at a point which was 39 meter away from the pole of the mirror. This is something like this. This is our convex mirror. Now the jogger is at this position. He is running. So his position is not fixed. So the jogger was first at position P. Now after 1 second, his position is changed to Q, and he is running in this direction. That means he is running in the direction of light. So we can say at P, his distance from the mirror will be, this is 39, this distance is 39 meter, and this part is 5 meter. This part is traveled in 1 second. To reach the point Q, jogger takes 1 second from the point P, and the distance of these 2 points is 5 meter. So now we can say this distance is 39 minus 5, that means 34 meter. So at this position, if we measure it from the pole, it becomes minus 34 meter. So it becomes, okay. So this is the initial position of the jogger, and this is the position after 1 second. This distance is 39 meter, and this distance, okay, is covered in 1 second, and this distance is 5 meter because the speed of the jogger is 5 meter per second. So PQ distance is 5 meter. So we need to find out this distance QP. Uh, okay, let us call this point P dashed. Okay, so the distance between P dashed Q is 39 minus 5, which is 34. So when the jogger is at point Q, the object distance will be minus 34, because we always measure distances from the pole, which is opposite to the direction of light. So after 1 second, the position of the jogger should be minus 34 meter. So I hope you have understood it. So the image, now we need to find out the position of the image. We know when an object is moving towards the convex mirror, the image shifts towards the pole. Okay, the image shifts towards the pole. So when we are moving an object towards a convex mirror, the image size increases and the image moves towards the pole. And when we move an object away from the convex mirror, the image size decreases and it moves towards the focus. So now in this case, we are going towards the mirror. That means the image is actually approaching the pole. Now let us find out the position of the image. So by mirror formula we can say 1 by minus 34 plus 1 by V dashed, let us call it V dashed, equal to 1 by focal length, which remains same, which is equal to 1. So 1 by V dashed is equal to 1 plus 1 by 34. Now if we invert the ratios, we can write 34 by 35. So this is our new position of the image, and this was our previous position of the image. So the difference between these two positions, so 1 second before this was the position of the image, and 1 second after, this is the position of the image. So the change in position of the image in 1 second, change in position of the image in 1 second is this. So we need to find out the difference, v minus v dashed, which is okay. So this gives us 5 by 1400. This is 1 by 280 meter. So the speed of the image is 1 by 280 meter per second. So this is our answer. I hope you have understood it. See the question carefully, and after that try to understand the solution. I hope you are able to understand it. That's all, friends, for today. Thank you.